Welcome students to online classes of mathematics for class 8. In this video we are going to study chapter number 11, which is mensurations of NCERT textbook. This was the session number 3 for this particular chapter. Here we are looking at the exercise 11.2. In the previous session we have already covered the first 5 questions of exercise 11.2. Now in the part 2 we will be looking at the remaining question, that is from question number 6 to question number 11. Okay. Myself Deepak Gautam, DGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start. As I said, we have already covered the first 5 questions of the exercise in the previous session. Now we are going to start with the question number 6. Question number 6 is find the area of a rhombus whose side is 5 cm and whose altitude is 4.8 cm. So we are given a rhombus whose one side, you can say base side, is 5 cm and altitude is 4.8 cm. And if one of the diagonal is 8 cm long, find the length of the other diagonal. Okay. So let's first draw its figure. We are having a rhombus like this, and we know all the sides in a rhombus are of equal measure. Okay. In this rhombus what we are given is one side is 5 cm. So one side is given to us as 5 cm long, and also the altitude of this rhombus is 4.8 cm. Okay. So let's draw its altitude, which is the perpendicular height, which is given as 4.8 centimeter. Okay, and also we are given that one of the diagonal is 8 centimeter long. That means we are given is one diagonal which is 8 centimeter long. Okay, so we are going to calculate this area using a formula which is base into height for a rhombus. Okay, so let's start first by writing the given information. We have answer number 6. What we are given here is base side of rhombus is given as 5 centimeter. Okay, and altitude of rhombus is equals to 4.8 centimeter. Okay, and also we are given one diagonal, that is, and or you can say also length of one diagonal is equals to 8 centimeter. Okay, and we have to find the length of the other diagonal. Suppose we are given this d1, we are going to find the length of the d2. Okay, so we have one formula to calculate the area of a rhombus, that is, as we know, area of rhombus is given by the formula, that is base into altitude. Okay, so that means base here is 5 centimeter, altitude is 4.8. so when we multiply this 5 into 4.8, we will get 24 centimeter square. So that's the area of this rhombus using the formula base into altitude. Okay, and we also know area of rhombus is given by the formula half into d1 into d2. Okay, that is the multiplication of the two diagonal. So area of rhombus we have calculated here, which is 24. We have this half, length of one diagonal is given, which is 8, and we have to calculate the length of the second diagonal. Okay, so this 2 when dividing this 8 will give us 4 here. Okay, so this d2 will be 24 divided by 4 equals to 6 centimeter. Okay, so hence the length of the other diagonal is 6 centimeter. Right, hence the length of other diagonal is 6 centimeter. Okay, so that's the answer of the question number 6. Now moving ahead to the next one, we have the question number 7. Question number 7 is the floor of a building consists of 3000 tiles which are rhombus shaped, and each of the diagonal are 45 centimeter and 30 centimeter in length. Okay, we have to find the total cost of polishing the floor if the cost of is per meter square is 4 rupees. Okay, so what we have here is we have a building whose floor is consist of a 3000 tiles, and each tile is in the shape of a rhombus. Okay, and the measurement of its diagonal are given, which is 45 centimeter and 30 centimeter long. What we have to do here is we have to find the cost of polishing the floor. If the cost of polishing is 4 rupees per meter square. Okay, so let's write the given information. We have here answer number 7. Okay, so what is given to us is there is a floor which is made up of 3000 tiles. So let's write number of rhombus shaped tile used in floor is equals to 3000. So number of rhombus shaped tiles used is 3000, and the measurement of the each rhombus is given. So let's first draw its figure. Okay, we have a rhombus shaped tile like this, whose two diagonals are given. One is 30 centimeter and other one is 45. Okay, so this longer one is 45 centimeter and this smaller one is 30 centimeter. Okay, so we have this diagonal 30 and 45 centimeter. So let's write it. And the first diagonal, or you can write and the length of first diagonal is equals to 45 centimeter. Okay, and the length of second diagonal is equals to 30 centimeter, and the rate of cost of polishing the floor is 4 rupees per meter square, and rate of cost of polishing the floor is equals to 4 rupees per meter square. Okay, now one thing that you have to notice here is that the rate of cost is given in meter square, while the measurement of the diagonals are given in centimeter. Okay, so first thing that we have to do is we have to convert all the unit into a same one, either this meter square into centimeter or this centimeter into meter square. So what we are going to do is we'll convert this centimeter to meter. So in order to convert this into centimeter, what we have to do is we have to divide this by 100. So this will become 0.45 meter. Okay, in similar way this 30 centimeter will become 0.3 meter when dividing by 100. Okay, so now we got the length of the two diagonal in meter. Now we're going to use this to find the area of the one tile. Okay, let's calculate the area of the one tile. Now the area of one tile will be equals to half into d1 into d2. d1 here is 0.45 and d2 is 0.3, and the common unit will be meter square. Now we have to multiply the two. This 45.45 into 0.3 will give us 0.135 meter square. So that's the area of one tile. Okay, and the number of tile used here is 3000. So the area of entire floor will be, therefore the area of entire floor will be equals to number of tiles multiplied to the area of one tile, that is 1.35 centimeter square. Okay, after multiplying the two, we'll get the result as 202.5 meter square. So that's the entire area of the entire floor. Now we're going to multiply this area by the rate of cost of polishing. Okay, so get the total cost. Okay, hence total cost of polishing the floor is equals to the total area, which is 202.5 meters square, multiplied to the rate of cost, which is 4 rupees per meter square. So we're going to write this as 4 rupees per meter square. Per meter square we can write this as divided by 1 meter square. Okay, when you solve this, the result will be 810 rupees. Okay, so that's the answer for this question number 7. Okay, so what we did is we are given the number of tile and the length of the diagonal. So we have calculated the area of one tile, then multiplying that area of one tile by the number of tile, we got the area of entire floor, and by multiplying the area of entire floor with the rate of cost, we got the total cost of polishing the floor. Okay, so that's the answer number 7. Now moving to the next question is, Mohan wants to buy a trapezium shaped field. Its side along the river is parallel to and twice the side along the road. So Mohan wants to buy a trapezium shaped field, which is this one. Its side along the river is here. The side along the river is parallel to and the twice in the length of the road. So suppose the length of this side is x, then the length of this side will be 2x. Okay. Further it says, if the area of this field is 10,500 meters square and the perpendicular distance between the two parallel sides is 100 meter. So we are given the area of this trapezium field and also the perpendicular distance between the parallel side. We have to find the length of the side along the river. Okay, so let's first draw this trapezium here. We have this trapezium shaped like field, okay, whose this side we are taking as x and this one as 2x. As it says, this side along the river is parallel to and twice the side along the road. Okay, and this perpendicular distance is also given, which is 100 meter. Okay, so let's write first the given things. This is answer number 8. What we have here is, let the length of side along the road equals to x meter, then the length of side along the river will be equals to 2x meter, as it's given in the question that it is twice and parallel. So if the side along the road is x, so this side along the river will be 2x. Okay, and the perpendicular distance between the two, and the perpendicular distance is 100 meter. Also we are given the area of field. Okay, also the area of trapezium field is given as 10,500 meters square. Okay, and we know the area of trapezium is given by the formula half into h into sum of the parallel side. Okay, so that will be, or we can replace this by the formula that is half into height into sum of parallel side, that is a plus b equals to area is given as 10,500 meters square. Okay, so we have this 1 by 2. Height of between the parallel side is 100 meter, and we have taken the one side as x and the second one as 2x equals to 10,500 meters square. Okay, now let's solve this. This 100 divided by 2 will give us 50 here. Okay, so let's move this 50 to the other side. It will be this x plus x, 2x will be 3x. This 50 when shifted to the other side will be 10,500 divided by 50 meters square. Okay, or this will be 3x equals to this 10 will cancel the 10 here. So what we left with 1050 divided by 5 is 210, or x from here will be 210 divided by 3 equals to 70 meter. Okay, so that's the length of the x. What we have to ask to calculate here is find the length of the side along the river, and we have taken that as 2x. Okay, so we'll write hence the length of side along the river, we have taken that as 2x, and x we have calculated, which is 70. So that is 2 into 70 meter is equals to 140 meter. So that's the answer of the question number 8 of 11.2. Now moving ahead to the next question. The question number 9 is the top surface of a raised platform is in the shape of a regular octagon as shown in the figure. Find the area of the octagonal surface. Okay, so we are given this figure which is in the shape of octagon, which means this is a polygon having 8 sides. Okay, like I told you, we don't have any particular formula to calculate the area of a polygon. So what we are going to do is we are going to divide this polygon into different sections. Okay, since we are having this side as 11 meter. Okay, so if we join these two vertices also, we get the figure divided into 3 sections, that is first, second and third. Okay, and you can see the first and the third are identical and both are in the shape of a trapezium, while the second one is a rectangle. Okay, so we are going to calculate the area of these two trapezium and also this rectangle, then we'll add the all three to get the total area of this octagonal surface. Okay, so let's start the answer number 9. Okay, so what we did is we have divided the given octagonal into 3 sections. Okay, 3 sections which are in the shape of 2 trapeziums, and one a rectangle. Okay, now let's calculate the area of the section 1. Okay, area of section 1, okay, which is a rectangle, sorry, trapezium. Okay, so let's write area of section 1 is equals to half into height into sum of parallel side, that is A plus B. So from figure it's given that the height here is 11 or 4, so we have 1 by 2, height is 4. The other parallel sides are, this side is given as 4 5. Since it's octagonal, that means the all 8 sides are of same measurement. Okay, since this is a regular octagon, so this side is also 5 meter. So A and B here are 5 and 11 meter. Okay, the common unit will be meter square. This 4 divided by 2 will give us 2, and this 5 plus 11 is 16, so this will give us 32 meter square. So that's the area of the section 1, and also that will be the area for section 3. Okay, so write also area of section 3 will be equals to 32 meter square. Okay, this is area of section 3 will be equal to 32 meter square because both are the trapezium. Now we're going to calculate the area of second section, area of section 2, which is a rectangle. Okay, so write area of section 2 is equals to length into breadth, which is a rectangle. Okay, so length here is 11 and height, breadth is 5. Length is 11 meter, breadth is 5 meter. We'll write the common unit here, 5 meter square, so 11 into 5 is 55 meter square. Okay, so we got the area of the all 3 section. So we'll write hence the area of octagonal is equals to area of section 1 plus area of section 2 plus area of section 3. That will be area of section 1 is 32 meters square, area of section 2 is 55 meters square, and again area of section 2 is 32 meters square. Now we have to add the 3 to get the area of the octagonal. Okay, so we have this 5 plus 2 plus 2 is 9. Now then this 5 plus 3 is 8, 8 plus 3 is 11. Okay, so the area is 119 meters square. Okay, so that's the answer of the question number 9. Moving to the next question now. Question number 10 is, there is a pentagonal shaped park as shown in the figure. For finding its area, Jyoti and Kavita, so there are two girls, Jyoti and Kavita, did it into two different ways. Okay, so this is a figure which is divided into two different ways. Kavita has divided it into two trapezium, while Jyoti has divided into two trapezium, while Kavita has divided into a square and a triangle. Okay, so we have to find the area of this park using both way. Can you suggest the other way to find the area? Okay, so what we're going to do is we're going to calculate the area of the both the diagram. Okay, so let's start the answer number 10. Okay, so first is finding area by Jyoti's diagram. That is, here the park is divided into two trapezium, is divided into two trapeziums. Okay, so we are going to calculate the area of the one trapezium and we'll multiply that by 2 to get the area of the second trapezium. Okay, so what we given here is, we have, since this side is 15, so the in this trapezium this side is 15 meter, this height total, this height is 15, so this half will be 7.5. okay, and this longer side is 30 meter. Okay, so we'll write the sides of the trapezium are, we have sides of trapezium are A equals to 15 meter, B equals to 30 meter, and H is equals to 7.5 meter. Okay, therefore the area of pentagon, therefore area of pentagon will be twice the area of trapezium. Okay, 2 into area of trapezium, that is 2 into area of trapezium is given by half into H into A plus B, so that will be 2 into 1 by 2 into H is 7.5 and the sides are 15 meter plus 30 meter, so this 2 and 2 will be cancelled. What will left with is 7.5 into 30 plus 15 will be 45, and this 45 into 7.5 will be equals to, okay, let's multiply the 2. After the multiplication we get the result as 337.5 meter square. So that's the area of this pentagon using through the Jyoti's diagram. Okay, now we're going to calculate the area of the same pentagon by Kavita's diagram. So let's write finding area. Now finding area by Kavita's diagram. That is here the pentagonal is divided into one square and a triangle. Okay, so this here, as you can see in the figure, this figure pentagon is divided into one square and a triangle. Okay, now we're going to calculate the area of pentagon. Now the area of pentagon will be equals to the sum of the area of triangle plus area of square. So that will be area of triangle will be given by half into, here the base will be this 15. Okay, also the height will also be 15 and the side of this square is also 15, so everything is 15 here. So it will be half into base into height. Okay, then we are going to add the area of square, that is 15 into 15. So this will be 15 into 15 here is 225 by 2 plus, then we have 15 into 50 is 225. Okay, so this 225 divided by 2 will be 112.5 plus this will be 225. After adding the 2 we'll get the result again as 337.5 meter square. So in both the cases we are getting the area equal. Okay, so that's how you can calculate the area of any given figure by dividing into different sections. Okay, now moving to the next and the last question of this exercise, we have question number 11 is the diagram of the adjacent picture frame has the outer dimension 24 by 28 centimeter and the inner dimension is 16 into 20 centimeter. We have to find the area of the each section of the frame if the width of each section is same. Okay, so we have this picture frame whose dimension are given. Outer dimension are 24 and the 28 centimeter and the inner dimension are 16 and 20 centimeter. Okay, so we have to find the area of the each section of this frame. You can clearly see that each section is in the shape of a trapezium, right? So we are going to divide this area into the 4 sections. That is, let's name it, this one is section 1, this one is section 2, this one is section 3 and this one is section 4. Okay, so now you can see that since this measurement is 24 and the inner side only is 16, so the remaining is 8. That means the width of this section is 4 centimeter. Also the width of this section is 4 centimeter. Okay, in similar way the total length here is 28 and only this section is 20 centimeter, so the remaining will be 4 centimeter here and 4 centimeter here. So that means this frame is divided into total 4 trapezium having the equal width. Okay, so let's start its answer. Number 11, what we have here is, since the width of each section is same, therefore area of figure 1, or you can say section 1, will be equals to area of section 2. Okay, also area of section 3 will be equals to area of section 4. Okay, so we're going to calculate the area of section 1, that will be the area of section 2 also. Similarly, we calculate the area of section 3, and that will be the area of section 4 also. Okay, so let's start. Now area of section 1 is equals to, because it's a trapezium, so this will be half into h into sum of parallel, that is a plus b. So half, we have here h height is same, which is 4. A plus b for the section 1 is, a is 28 and b is 20, so it is 28 plus 20 centimeter square. Okay, so this 4 divided by 2 will give us 2 here. This 28 plus 20 will give us 48. By multiplying the 2, you will get 96 centimeter square. Okay, so that will also be the area of section 2. Okay, so hence the area of section 2 will also be equals to 96 centimeter square. Okay, now we're going to calculate the area of section 3. Okay, now the area of section 3, that will be again a trapezium, that is half into h into a plus b for the section 3. Okay, so we have this 1 by 2, h here is again 4, and parallel side here are for section 3. Parallel side will be, this will be 24 and this is 16. Okay, so sides are 24 into 16 centimeter square. So again this 4 divided by 2 will give us 2 here, is 16 plus 24 will give us 40. So by multiplying the 2 will get 80 centimeter square. Okay, so we'll write also the area of section 4 is equals to 80 centimeter square. Okay, so we have got the area of the all 4 section of this photo frame. So, and we have completed the question number 11 of the exercise 11.2. okay, with this we have completed all the question of exercise 11.2. okay, hence we have concluded the exercise 11.2. now you have to practice all this question multiple times so that you understand better. Okay, so that's all for now. Thanks for joining here, everyone.